Good day, viewers all over the world. It's good to have you in class again today. My name is Dr. Chris Esekaibe. I am the owner of this YouTube channel. I teach key topics in mathematics and statistics. I'm a specialist in numerical analysis, data analysis and modeling, scientific computing, and applied statistics. I am a chief lecturer in one of the most prestigious polytechnics here in Nigeria, and I'm also a member of the academic board of that same institution. I have university lecturing experience and also have lectured in an advanced AI college here in Nigeria, where we teach students advanced mathematics in an Ontario diploma program and also the IGF Foundation program with the British Council. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor degree in statistics. I've written quite a number of books in numerical analysis and applied statistics, and I have renowned publications, and I've also presented papers in renowned conferences within and outside Nigeria. I am a mathematician cum statistician. I train AI models. I have been privileged to work with 2 AI firms in the United States of America, where I did remote jobs with the 2 AI firms. I assisted in creating prompts, training the models, creating a chain of thoughts, rubrics, and also golden responses to train these models. If peradventure you are an AI firm, you deal with that, you train AI models, you can consult me to be part of your team of mathematicians or statisticians that train your AI model. I will be glad to hear from you. Or if also you are a research institute, you do a lot of statistical research or mathematical research in numerical analysis, I will be glad to hear from you so that I can be part of what you are doing. My contacts are +234 8033021903. This first contact is for call and WhatsApp. Then the second contact is +234 7066297535. My email address is chrisdavids2015@gmail.com. I will be looking forward to hearing from you. I have quite a number of videos in my YouTube channel. You can also check me on my LinkedIn. I have my LinkedIn. Of course, you can see more of me there, and I will be looking forward to hearing from you. So, beloved, permit me to go to the business of the day. We want to see how we can use the Newton-Raphson method to solve a system of non-linear equations. At a point in this YouTube channel, we looked at a system of linear equations, but today we want to look at a system of non-linear equations. For those of you who have subscribed to my YouTube channel, I want to appreciate you. Thank you very much for subscribing. Thank you for sharing my videos in all your social media platforms. The essence of this YouTube channel is to share videos, to share knowledge in key areas in mathematics across the globe. For those of you who have subscribed and have been sharing my videos, thank you very much. And for those of you who have been watching my videos and you are yet to subscribe, please, I want to appeal with you to subscribe. Or if peradventure you are a first viewer, please subscribe, share my videos in your social media platforms, and as you do, God will bless you and reward you richly. Thank you very much. Now we want to go into the business of the day, looking at a system of non-linear equations. So by introduction, let me first of all explain the Newton-Raphson method. The Newton-Raphson method. How it works, In one of the videos, we looked at the Newton-Raphson method for solving algebraic and transcendental equation. But that approach is quite different from this approach we are looking at today, because we are looking at a system of non-linear equations. Now let x naught y naught be an initial approximation. Be an initial approximation. Be an initial approximation to the root of the system. To the root of the system. The system is given as this: f of x, y equals 0. Then, of course, g of x, y equals 0. So this is the system of non-linear equations that we are to solve. And you can call this equation 1. This is the system of non-linear equations that we want to solve. Now, this first one is a function of x and y. Then the second equation is also a function of x and y. Now, please follow me carefully. If x naught plus h, y naught plus k is the root of the system, if that is the root of the system, then we have f of x naught plus h, y naught plus k to be equal to 0. Then of course we have the second equation, which is g of x naught plus h, y naught plus k is equal to 0. You can call this equation 2. Now you need to understand that this is the system, and of course our initial root is given by x naught, y naught. Of course there will be an initial approximation of the system, so that is x naught, y naught. So to get successive roots, of course you see that x is increasing by h and y is increasing by k. So that is what we expect to do. You will see that for you to get x1, for instance, you need h to be added to x naught to get x1. For you to get y1, you need k to be added to y naught to get y1. Now, assuming that f and g, the two functions f and g, are sufficiently differentiable. Now, assuming that f and g are sufficiently differentiable, then we expand by Taylor series. Then we are going to get, permit me to share the board into 2 equal parts. Then if we carry out this expansion by Taylor series, then we are going to have our f naught plus, of course it will be partial derivative h del f all over del x naught plus k del f all over del y naught plus is equal to 0. That is for the first equation. Then for the second equation, we are going to have g naught plus h del g all over del x naught plus k del g all over del y naught plus that is equal to 0. So you can see, now you must understand that for us to get our f naught, of course, definitely f naught simply means f into x naught comma y naught, while g naught simply means g into x naught comma y naught. That is what f naught and g naught mean. So if you have that, we have done the Taylor series expansion. Then we need to take a step further, neglecting the second and higher terms. We have neglecting second and higher terms. We have, so this is now the key equation we are going to be using for the Taylor, for the Newton-Raphson method. So we are going to have this as h del f all over del x naught plus k del f all over del y naught. It will now be equal to minus f naught. This f naught goes to the other side of the equation. Then for this second equation, we are going to have h del g all over del x naught plus k del g all over del y naught. This will now be equal to minus g naught. This g naught goes to the other side. So this equation becomes the star equation for the Newton-Raphson method that is now used to solve the system of non-linear equations. So this is readily solved by the time we impute values into or parameters into this key equation, this key Newton-Raphson equation. That means we are going to be solving for values for h and k. So when we solve for values for h and k at the first iteration, then definitely, like as I said, our x1 will be gotten by x naught plus h. Our y1 will be gotten by using y naught plus k. So the mesh size for increment for the x value is h, y dot for increment for the y values is k. So these two equations will now be solved simultaneously for h and k, so that we can keep on approximating values for y and x. So the process continued until the desired accuracy is obtained. So this is the Newton-Raphson key equation for solving a system of non-linear equations. That is what it means. So we are going to have this as we are going to put this into consideration. So now we want to go ahead and see how we can solve a problem. So permit me to clean this part of the board. I believe you have learned something. So let's take a step further by solving a particular example. This implementation, we want to implement this particular formula in solving a particular problem. Now, the example says, it says, find the real root of the equations. Find the real root of the equations. What are the equations? The equations are x squared minus y squared is equal to 4. You can call this equation 1. Then the second one is x squared plus y squared is equal to 16. So you can see these are two equations that should be solved simultaneously, but now we are using a numerical method, which is the Newton-Raphson method we just explained. Now you can say this is a system of nonlinear equations. The first equation here is x squared minus y squared equals 4. Then the second equation is x squared plus y squared equals 16. So now we need to really understand that, first of all, we need to see how we can get an initial approximation. So let us call this first one equation 1, and let us call this second one equation 2. Now we want to see how we can go. Now the first thing we need to do is to ensure that we have the particular problem resolved. So from equation 1, this equation 1 here, it is easy to see that from here our x squared will be equal to 4 plus y squared. You can call this equation 3. Now you can now say putting 3, this equation 3 into equation 2, we now have putting 3 into 2. That means anywhere you see x squared, you are going to put 4 plus y squared. And equation 2 is x squared plus y squared. So our x squared will now be 4 plus y squared, which is representing x squared, then plus this y squared here, plus y squared is equal to 16. So this implies that from here we have 2y squared is equal to 16 minus 4 is equal to 12. So it's equal to 16 minus 4. So from here our y squared will be equal to 12 all over 2, and that is equal to 6. So our y squared is 6. Our y squared is 6. Then this simply means that you can call this equation 4. Our y squared is 6. You can call this equation 4. So from there, putting 4 into 3. Now you come here, putting equation 4 into 3. What is equation 3? Our x squared equals 4 plus y squared. So if you have that, that means our x squared will be equal to 4 plus, what is our y squared? 4 plus y squared. Our y squared is 6. 4 plus 6, that is equal to 10. So you can see that we have been able to get this. This simply means that x will be equal to root 10. And of course, we know we got our y squared to be equal to 6. This implies that our y will be equal to root 6. So you can see from this, we can make an attempt to choose a starting value. Now, you need to please take note of this key equation. This is the key equation for the Newton-Raphson method. Permit me to clean this part of the board as we make progress. Permit me to clean this part of the board. Take note of that equation. We are going to use it as we make progress in this particular topic. So please just follow me carefully as we go. So now to apply the Newton-Raphson method, a starting solution is necessary. Hence, we have to replace the hyperbola. Of course, that is a hyperbola by means of its asymptote. So replacing the hyperbola by means of its asymptote, we come here, it simply means that here your y will be equal to x. Now look at what x is. From this will guide us to choose a starting value. So from this particular problem here, you can see x squared minus y squared equals 4. That's the first equation. X squared plus y squared equals 16. That's the second equation. Now choosing a static value using the Newton-Raphson method, of course, you can see that y is equal to 2 because y is equal to x because it is a hyperbola. That is what the problem is. The problem is a hyperbola. Then if you make that, then if x is root 10, then y is root 6. Then it simply means that we can choose a starting value to make x and y equal. Then of course 6 plus 10 is 16. When you divide it by 2, of course we can now choose this to be equal to root 8. So this will now give us 2 root 2, and of course now we'll now get our x naught to be equal to 2 root 2, and that is equal to 2.828. Then our y naught will be equal to 2 root 2, and that is equal to 2.828. That is now our starting value for the particular problem. Now, if we have this, remember from the we have two particular equations here. The first one is f, the second one is g. If you remember the definition that we gave when we were deriving that particular key equation for the Newton-Raphson method, of course here our f, look at our f here, our f will now be equal to x squared minus y squared minus 4 is equal to 0. The right hand side is always equal to 0, so this 4 will be shifted inward. Then the second equation is our g, and that will now be the second equation. That will be x squared plus y squared minus 16, because the right hand side is always equal to 0. So this 16 will be shifted to the left hand side, making the right hand side to be equal to 0. Remember the key equation that we have. Let me write the key equation so that we don't mess it up. We have h del f all over del x naught plus k del f all over del y naught, and that is equal to minus f naught. We have h del g all over del x naught plus k del g all over del y naught, and that is equal to minus g naught. So this is the key equation, the star equation for the Newton-Raphson method that is used to solve a system of non-linear equation. Now, if this is our f and this is our g, then of course we need to get these values. So now from here, my del f all over del x naught will now be equal to, look at it, I'm differentiating f. This is my f with respect to x. This will be 2x naught. Then my del f all over del y naught, I'm differentiating with respect to y. Of course, this is minus y squared. That will be equal to minus 2y naught. Then I'll come again, my del g, this is partial derivative, del g all over del x naught. This is g. If I differentiate x squared, of course, that will be 2x naught. Then my del g, I'm differentiating g partially with respect to y, all over del y naught. If I differentiate partially with respect to y, this will also give me 2y naught. So these are the things that we need to carry out this particular solution. Now, permit me to move further. Let me clean this part of the board so that we will have enough space to write. So take notes of what we have been doing. I hope you are following the class. Please, if you are a first time viewer and you have not subscribed to my YouTube channel, please subscribe and share the videos in your social media platforms. Again, for those of you who have subscribed, I really appreciate you. Thank you very much for subscribing. Now, putting all this into this key equation, into the star equation, of course, we have our h. What is our del f all over del x naught? Del f all over del x naught is, we have, okay, permit me to clean this. Del f all over del x naught, that is 2x naught h. Of course, this h is there. Then, of course, there is a plus. Then del f all over del y naught is minus 2y naught. So this will be minus 2y naught. Of course, there is a k here, k, and that is equal to minus f naught. Then you come to the second one, del g all over del x naught. That when we talk about del, is partial derivative. So del g all over del x naught is 2x naught. So you have 2x naught. Of course, there is an h there. 2x naught h plus del g all over del y naught is 2y naught plus 2y naught. Of course, there is a k there, k, and that is equal to minus g naught. So we are making progress. You can see how we have started using the k equation. So the first thing for us to get here is to get our f naught and g naught. Our minus f naught will be equal to minus into, now look at everything that has to do with f here. So this will be, it will now be minus x naught squared minus y naught squared minus 4. This is the for anytime you are using talking about f, this is the equation. The right hand side must be 0. So putting these values, minus f naught will now be equal to minus into, what is our x naught? 2.828 squared minus, what is our y naught? 2.828 squared minus 4. So by the time you have that, of course, this minus this will be 0, minus 4, that will be equal to plus 4. Then our minus g naught will be equal to minus into, anytime you're talking about g naught, you are using this, so it will be x naught squared plus y naught squared, because we are at the first iteration, then minus 16. So anytime you're talking about g, because the equations are 2, f and g, so you come in and minus g naught. Minus g naught will be equal to minus into, what is our x naught? 2.828 squared plus 2.828 squared minus 16. So when you carry that out, you are going to have minus g naught is now equal to minus into, when you get that value, of course, when you carry out this arithmetic, you are going to have minus 0.004832. So minus will now become, it now become 0.004832. So that will now become our g naught. So by the time you have that, you are coming here, you can see we are going to work on this particular system of equation, these two systems now. Since we have values for our minus f naught and minus g naught, you come here, you put 2, what is our x naught? 2.828 into h minus 2 into 2.828, that is for y naught, into k is equal to, what is minus f naught? Minus f naught is 4. Then you come here again for the second one. This will be 2 into 2.828 into h plus, of course, 2 into 2.828 into k is equal to, what is our minus g naught? Our minus g naught is 0.004832. So we have these two systems of linear equations to solve for h and k. So at each point of iteration, there is a system, there is a 2x2 system of equations to be solved simultaneously. So permit me to move to this other part of the board. Please, I hope you are following keenly. Let me clean this part of the board so that we can use it to continue. I hope you have taken note of the key equation. So we continue like that. So coming here now, carrying out this multiplication, 2 times 2.828 will give us 5.656. So you come here, 2 times this will be 5.656h minus 2 times that minus 5.656k, and of course is equal to 4. Then for the second one is the same thing. It will be 5.656h plus, of course, because there's a plus here, 2 times this will be 5.656, of course there is a k here, and that will be equal to 0.004832. So you have that. Now there is a simple task we are going to do. Divide these two equations, divide all through by 5.656. Of course, you are going to have h minus k is equal to, when you divide 4 by 5.656, you are going to have 0.7072. Then divide all this again, you are going to have h plus k is equal to, divide 0.004832 by that, of course, approximately you are going to get 0. Of course, you are going to take this as your new equation 1, this as your new equation 2. So from equation 2, our h is equal to minus k. You can call this equation 3. So you can now say putting this equation 3 into equation 1, we now have, anywhere you see h, you put minus k. There is h here, so you have minus k. Then of course there's another minus k here. It's equal to 0.7072. By the time you have this, then of course minus 2k is equal to 0.7072. So k alone will be equal to 0.7072 all over minus 2. And that will give us minus 0.3535. Minus 0.3535. So that's our k. Remember, our h is equal to minus k. So our h will be equal to minus into minus 0.3535. And that will be 0.3535. So our k is minus 0.3535, while our h is 0.3535. Now, if you come here, okay, 3636, okay, if you come here, 0.3536. So that is what you have. Now, if you come here, you will see that the approximation for us to get x1, our x1 is equal to x0 plus h. Then, and that will be equal to, our x0 is 2.828. 2.828. Then what is our h? Our h is 0.3536. So our x1, when you add 2.828 to 0.3536, you are going to have 3.1816. 3.1816. That is our x1. And of course, our y1 is simply y0 plus k. And that will be equal to, what is our y0? Of course, y0 is the same thing as x0, is 2.828. Then what is our k? Our k is negative, so you put minus 0.3536. So our k, okay, that means our y1 will be equal to, when you carry out that arithmetic, 2.828 minus 0.3536, you have 2.4744. 2.4744. So you can see we have been able to get values for our x1 and y1. So permit me to clean this part of the board so that we can continue. It is as simple as ABCD. You can see that we are making a very good progress. Please, if you have not subscribed to my YouTube channel, try and subscribe to the channel, Dr. Chris Isekaibe. The essence of the channel is to solve problems in key areas in mathematics and statistics, and by so doing, we are to share knowledge across the globe. And for those of you who are yet to subscribe, please subscribe. For those of you who have subscribed, I am very grateful. Thank you very much. So now we have to repeat this process. So we have to replace, now we need to get values for y2, x2, y2. We need to get value for x3, y3, and so on and so forth. So we can write it as this: x1, y1 will now be equal to, what is our x1? Our x1 is 3.1816. Then our y1 is 2.4744. That is what we have. Now we want to get x2 and so on and so forth. This simply means that to get x2, our x2 will be equal to y1, our x2 will be x1 plus h. Our y2 will be equal to y1 plus k. So you need to get new values. You need to solve another system of 2x2 equation to get new values for h and k. Now what do you need to do? Replacing x0, y0 with x1, y1 in that particular system, and repeating the process. We have, when you do this and you repeat the process, you will see what we are going to have. This is as simple as ABCD. So you come here, we are now going to have 2x1h minus 2y1k is equal to minus f1. So we are still going to get 2x1h plus 2y1k is equal to minus g1. So you must understand that, again, your f1 will be equal to x1 squared minus y1 squared minus 4. That is what you need here. Then of course, your g1 will be equal to x1 squared plus y1 squared minus 16 from the particular problem. So if you put in these values, you get value. Of course, you know what your x1 is. Your x1 is 3.1816. You put it here. Of course, this will now be having value of h. Your y1 is 2.4744. You put it here. Put s1 equal there. To get the value of your f1, you come here and put x1 squared. This guy is 3.1816 squared minus 2.4744 squared minus 4. You get the value. You put it here. Then you are going to solve simultaneously. Then you will now arrive at your answer. You will now arrive at h. This is the final answer you will arrive at. I'll give you the answer. If you need to test on it, work on it on your own, you're going to have h is equal to minus 0.0204, while our k will be equal to minus 0.0242. So when you solve this system, and by so doing, of course, our x2 is this. So our x2 will be equal to, of course, is x1 plus h. That is equal to, what is our x1? 3.1816. Then, of course, h is this minus 0.0204. 0.0204, and that means our x2 will be equal to 3.1612. Then of course our y2 is y1 plus k, and of course what is our y1? 2.4744 minus our k is minus 0.0242. Then of course our y2 will be equal to 2.4502, and it goes on like that. Now let me just quickly write a particular statement that you need. So you can see that if you continue this way, you continue like this, permit me to clean this part so that I can write a statement that will be useful to us in case you are interested in getting value for x3 and y3. It continues like that. Now that you have gotten that, if you want to get value for x3 and y3, definitely you come here, you replace, now you replace x1, y1 with x2, y2 to get our x3. So now we are going to use this 2x2h minus 2y2k is equals to minus f2. Then you come here again, 2x2h plus 2y2k is equal to minus g2. And of course, for you to get your f2 will be equal to x2 squared minus y2 squared minus 4. Then our g2 will be equal to x2 squared plus y2 squared minus 16. You can see now it's replacing. Then of course you need to, you already have value for, of course, our x2, y2 as given by the value. What's our x2? That will be 3.1612. Then our y2, 2.4502. Of course, these are the values you put in there. Then at the end of the day, your x3 will be equal to x2 plus h. Your y3 will be equal to y2 plus k. That is how it continues. So it is what you can keep doing when you put, it's an assignment I'm giving you from these two equations. What is your h and what is your k? So after putting all these values here into this key equation, you will solve simultaneously to get the values for h and k. It keeps on like that. To get your x4 and y4, you need to replace your x2, y2 with x3, y3. It keeps going like that until your desired accuracy is obtained, until your desired accuracy is achieved. Beloved, this is how the Newton-Raphson method works for solving a system of non-linear equations. I hope you have been able to follow the video from the beginning to the end. The class, of course, is quite interesting. You have seen how the Newton-Raphson method can also be used to solve a system of linear equation. Not only can you use the Newton-Raphson method to solve algebraic and transcendental equation or polynomial equation, we can also use it to solve a system of non-linear equations. Beloved, it's nice having you in today's class. For those of you who have subscribed to my YouTube channel, I'm very grateful. I say thank you. God bless you. For those of you who are yet to subscribe, I'll be looking forward to your subscription. Share the videos in your social media platforms. And of course, if you are an AI fan, I'm a mathematician cum statistician. I train AI models. You can consult me to be part of your team of mathematicians and statisticians that train AI models. I'll be glad to contribute my own part to what you are doing. And if you are a research institute, you are looking for statisticians and mathematicians to join your team of researchers, why not? I can be part of that. My contacts were displayed at the beginning of this video. My email address was also displayed. Of course, if you are a research student or an MSc student, a postgraduate student, I have postgraduate students who consulted me from Malawi, from Uganda. You can also consult me with your research work if you are doing a research work in mathematics or you are specializing in numerical analysis or statistics. Why not you can consult me. My consultation for postgraduate students is for free. I don't collect money from postgraduate students. I don't collect consultation fee. I will just send me a WhatsApp message or send me an email. I will respond accordingly, and the services I will be rendering to you, the services are for free. God bless you. Thank you for your time again. See you in our next video. Enjoy the rest of the day. Bye.